Hello students, welcome to RD Chemistry. In this video, I will briefly explain the reactions of carboxylic acid and then we will solve some problems. Right? Carboxylic acids are acidic in nature, right? Therefore, they can react with the metals like sodium, potassium, calcium, zinc, and they form corresponding salt and hydrogen gas be liberated. And suppose we make use of sodium hydroxide, it forms sodium salt of carboxylic acid and water. When it reacts with ammonia, initially it forms ammonium salt of the carboxylate ion. This will lose a molecule of water on strong heating. So therefore we get amide RCONH2. Okay. So this is the amide that is formed. Carboxylic acid reacts with the PCl5, PCl3 and thionyl chloride to give acid chlorides. And what is the best method here? Thionyl chloride is the best method because the side products formed are RCOCl. Then sulfur dioxide, the gas escapes out, and hydrochloric acid on strong heating it also escapes out, therefore leaving behind pure acid chloride. So thionyl chloride is one of the best method. P2O5 is a dehydrating agent. It removes water molecule from 2-carboxylic acid. If I write RCOH twice, there is an intermolecular dehydration taking place to give RCO twice and then attach the oxygen like this, right? So P2O5 is a dehydrating agent. Then we make use of mixture of sodium hydroxide, calcium oxide, which is known as the soda-lime mixture. What is this? Soda-lime mixture. And this process is called as the decarboxylation. So you can remember, if the carboxylic acid has been given, remove this carbon dioxide and simply write RH there. Okay. Now what is the use of calcium oxide? Calcium oxide is required to absorb moisture from the salt that is present. It should be a dry salt. Okay. Then carboxylic acid on the electrolysis, which is known as the Coles electrolysis method, which we have studied in the first PUC alkane chapter. Here, just like the Wurtz reaction, two R groups are alkyl groups are going to combine. And finally, we have got reaction with the lithium aluminum hydride, which is known as the strongest reducing agent. So it reduces the carboxylic acid to the primary alcohol here. Okay, primary alcohol. Clear? We have got some special reactions of the carboxylic acid like esterification reaction, and esters have got fruity smell, a pleasant smell. Okay. So here carboxylic acid reacts with the alcohol to give ester. This is an ester. Okay. So we'll have to remember here hydrogen from the alcohol, OH from the carboxylic acid removed to give water molecule. If I take acetic acid and the ethyl alcohol, then it gives ethyl acetate, okay, which is a fruity pleasant smell compound here. Okay. One of the important method here is HVZ reaction, Hell-Vollard-Zelinsky reaction. Here carboxylic acids having alpha hydrogen atom, they undergo either chlorination, bromination, iodination in the presence of red phosphorus to give alpha halo acids. Now with respect to COH group, next carbon is alpha carbon and hydrogen present on them are called the alpha hydrogen. Replace one of them. So it is a chloroacetic acid we are going to get. If I take propanoic acid with respect to COH, next carbon is alpha and hydrogen is alpha hydrogen. So we are replacing one alpha hydrogen by the chlorine. Okay. We can again continue with the reaction. We can get dichloro compounds also. Okay. Now let us see what is the significance of this HVZ reaction. What is the use of the product form? We can convert this product form to some other function group. Let us see. Now see here we have got say chloroacetic acid. If I treat with the KOH, Cl will be replaced by the OH. Nucleophilic substitution reaction. Also this is a carboxylic acid reacts with the base to give potassium salt. Then what is done is, to remove this potassium salt, it should be acidified with a dilute acid to give, instead of alpha chloro, alpha hydroxy carboxylic acid. Correct? Now see here, Cl can be replaced by the other nucleophiles like ammonia in alcoholic medium to give alpha amino compounds. Also remember, we have got ammonia. Ammonia also reacts with the carboxylic acid to give the ammonium salt of the carboxylic acid. Okay, which is then acidified. The salt should be acidified to give corresponding carboxylic acid. So this is the alpha amino acid. Okay, right? And this is the one of the simplest amino acid, and this is known as the called as the glycine. This is called the glycine. Okay. Now next one, with the one more nucleophile, cyanide. Cl can be replaced by the cyanide group, and cyanides on hydrolysis, they give rise to the carboxylic acid. Given carbon atom attached to 2 COH is called as the malonic acid. We have got carboxylic acid like this, dicarboxylic acid. This is the oxalic acid. If there is a one extra CH2 group in between, this becomes the malonic acid. Okay, right? Yeah, see this question. In the following set of reaction, acetic acid yielded the product D. Identify the product D. Thionyl chloride is a chlorinating agent, replaces the OH group. So compound A should be CH3COCl, correct? It reacts with the benzene and anhydrous aluminium chloride. Recall the reaction, benzene with the anhydrous aluminium chloride and acid chloride is a Friedel-Crafts acylation reaction, correct? So therefore, I should get benzene ring attached to the CO, and here it is a CH3. Fine. Now this should be in the form of C double bond because it's a ketone. Now there is the addition of hydrogen cyanide, H plus and Cn minus. H plus goes to the oxygen and Cn goes to the carbonyl carbon. So carbon oxygen double bond becomes single bond. So the product C should be benzene ring. Then C, it is a OH form. Then cyanide goes to the carbonyl carbon. Then we have got other side CH3. Okay, this is a product C. And this is hydrolyzed. Cyanides on hydrolyzed gives the corresponding carboxylic acid, that is a benzene, that becomes COH, and that nitrogen will be formed as the ammonia, then becomes ammonium salt later. Then this is the CH3 and this is the OH that is formed, correct? Now you identify where this product is now. So given carbon attached to OH and COH is there here, and CH3 attached and benzene, correct? So answer is option number 1. Clear? Question number 2. The acid D, it is obtained through the following sequential reaction. Now if I take a ethyl bromide CH3, CH2 and Br, we are using alcoholic KOH. Alcoholic KOH is known as the dehydrohalogenating agent. Removes HBr from the neighboring carbon atoms. So A should be alkene, that is the CH2 double bond CH2. Alkene then reacts with the bromine carbon tetrachloride. Addition reaction. So Br atoms are added across carbon-carbon double bond becomes single bond. Then there is a excess Ka plus and Cn minus. Cn minus act as a nucleophile. Nucleophile can replace the bromide ions. Therefore CH2 Cn CH2 Cn replace Br by Cn. When this compound subjected to hydrolysis, Cns are hydrolyzed to give COOH. Okay, remember cyanides are hydrolyzed to give COOH. Correct? So what is this compound? This compound is called as the succinic acid. Okay, succinic acid is a CH2 COOH and CH2 then COOH. Oxalic acid is the COH and COOH. Malonic acid is the CH2 attached to COH and COOH. Okay. Malic acid and fumaric acid are the geometrical isomers. Malic acid is a carbon, 2 carbon double bond. Then there is a COH on the same side. This is the cis form of the dicarboxylic acid, malic acid. If there is a trans form, it's called the fumaric acid. Okay, so for this question, answer is option number 1, right? Acetic acid is treated with the metallic sodium. Acetic acid is the CH3COOH treated with the sodium metal. So acid base reaction to give CH3COOH Na and the hydrogen gas, half mole of the hydrogen gas. So hydrogen X is formed. So this is the salt X. When X is heated with the soda lime mixture, sodium hydroxide and calcium oxide, they are given sodium carbonate. It forms sodium carbonate, Na2CO3, Na2CO3. So what is remaining? CH3, and here hydrogen is attached to it. Okay, so we get now here which molecule? Methane CH4. Or remember, corresponding carboxylic acid treated with the sodium hydroxide and calcium oxide, it undergoes decarboxylation in the form of sodium carbonate to give RH. So only one carbon atom remaining there in the R group, therefore it is a methane CH4. So answer is option number 4, that is a Y compound that is formed, right? Question number 4. Both organic compounds A and B can release hydrogen with the sodium metal. Reacts sodium. This is a ethane. Ethane also reacts sodium metal because ethanes are acidic in nature. Acid and ethane reacts. Acid and ethyl alcohol reacts. Ethyl alcohol and acetic acid also reacts. Okay. Only compound A can form salt with the sodium hydroxide. Alcohols and ethane cannot react with the sodium hydroxide. So A only reacts with the sodium hydroxide. That means first compound should be the carboxylic acid. Carboxylic acid is the second option and the third option. They can form sodium salt with the sodium hydroxide, whereas B cannot. Okay. When A reacts with the B in the presence of concentrated sulfuric pleasant smelling compound, fruity smelling compound. Fruity smelling compound is just called as the ester. Therefore, generally esters are formed with the alcohol and carboxylic acid. Therefore, answer is option number 3. Clear? Next question. In the following sequence of reaction, you would identify the product C. Okay. This is ethyl bromide, haloalkane. There is a nucleophile Cn minus. So therefore, product is a CH3Cl. Correct. This is the product A. Now, it is subjected to acid hydrolysis. Hydrolysis of cyanide gives a corresponding carboxylic acid, then ammonium salt. Okay. So this is a product B form. Reacts to the lithium aluminum hydride. Lithium aluminum hydride is the strongest reducing agent, correct? Therefore, it gives finally the corresponding alcohol with the same number of carbon atoms. So we are going to get here ethyl alcohol. Ethyl alcohol is there in option number 4. Option number 4, right? Let's go for the next question. Compound X and Y gives effervescence the sodium carbonate. Sodium carbonate gives effervescence, means it gives carbon dioxide gas. Okay, we can see in the test tube bubbling, effervescence. Effervescence with the sodium carbon possible only with the carboxylic acid. That means both the compounds should be carboxylic acid. So on the option number 1, there is a formic acid and the acetic acid. Both are giving the effervescence. Here, acetaldehyde does not react to sodium carbonate. Acetone does not react to the sodium carbonate. And here, acetone does not react. So the answer is the first option. Let's proceed. This is the X compound, this is the Y compound. X gives a precipitate with the ammoniacal silver nitrate. Ammoniacal silver nitrate is a tolerance reagent. Tolerance reagent generally reacts only with the aldehydes but not with the ketones, not with the carboxylic acid. But this X is a formic acid with the structure HC double bond OH. Now there is a carboxylic acid group. Also there is a aldehyde function group. So this is the only one carboxylic acid. There is the formic acid, methanoic acid which contain aldehyde as well as the carboxylic acid function groups. So therefore, since there is aldehyde group, it can answer tolerance reagent. Y gives sweet smelling compound ester on reaction to the alcohol. You know that acetic acid can react to the alcohol to give fruity smell esters. So therefore answer is option number 1. Okay. Student, please do subscribe, like and share the videos. Thank you for watching. Have a nice day.